Okay. Got it. Awesome. I'm still struggling. Cool. Okay, welcome everybody. First of all, apologies, I forgot to update the slides. We did not go back a month in time. As far as I know, also the live stream is working, so we're all good to go. So with that, let me first start. In the spirit of reconciliation, the Melbourne AWS user group acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respect to the elders past and present and extend that respect to all Aboriginal and Torres Strait Islander people today. So with that, what do we have today? It's our usual thing. Also, as you may have noticed, those of you who've been here before, first, welcome back. Also, I'm not Rob. Rob is currently on honeymoon, so I think we can all say congratulations to him. Yep, thank you. So I'll be going through the introductions. That's just normal thing. After that, Matt will be joining me to quickly discuss the news, after which we've got Peter here at the front, who will be telling us serverless stories, which sounds very interesting. And after that, we've got Dawn, who will talk all about securing CDK bootstrap stacks. We'll end the day with a usual marketplace to see who's hiring, and then we'll all go home. Well, if you don't want to go home, we'll go to a bar or whatever you want to do. I'm not judging. So, as always, ask questions if you need to, or if you want to. You can save them till the end. If you're watching online, we'll be keeping an eye on the chat, both on Slack and YouTube. Nobody ever asks over Twitter, so we don't even look at that anymore. And we'll ask those questions in your stead. If you have a question at the end of the talk, please raise your hand so we can bring the microphone, and people listening, watching live will also be able to hear the question, which is actually what this slide is all about. As always, yes, there's a code of conduct. It's very straightforward. Be nice to each other. There's more details on the websites or on the slide here, but that's what it comes down to. Of course, we couldn't put these events together without our sponsors. Our gold sponsor is CMD Solutions, and our silver sponsors, Versant and Civo. And of course, our venue sponsor, NAB, without whom we wouldn't be in this beautiful building. So thank you, sponsors. If you're not yet on our Slack, it's a great way to stay in contact with us. There's a lot of chatter going on, interesting channels about outages, announcements, people asking questions, all the things. Even a channel where we make fun of issues in the console, which is probably the most interesting channel. And of course, the other thing is we're always looking for people to help out. Most importantly, our speakers. So if you want to give a talk, reach out to me, Matt, Don, or anyone, Rob, if he's around. Just, every talk is a good talk. There's always somebody who will learn something from it. So don't feel like you don't have anything to bring to the table. Sponsors, we are currently working on a sponsorship for the next year. So if your company is interested in sponsorship, probably best person to talk to is Matt at the back there. Please do. Sponsors are great. And volunteers as well. There's always one or two tasks that can be done. Cool. What else is happening in the future? There's this small event coming up called reInvent. If you haven't heard of it, it's this thing where one or two people who like AWS come together in Las Vegas, meet up with the 50,000 closest friends, and basically have a good time. Is anybody going? Speakers and several people. That's good. Unfortunately, I won't be there this year, but that can't be helped. A bit closer to home, we keep talking about Peter, who's one of the organizers of the serverless meetup, which is running, it's not next Tuesday, the Tuesday after, because next Tuesday, nobody's working. There were no details yet about the talks. Sorry. I'm sure they'll be good. And if you keep wanting to go, the next day, the programming and tools has how to build a fitness activity tracker using machine learning on AWS, which will be given by Mike Chambers. So that's also promising to be a good talk. And with that, we've reached the end of what's on, and we'll move on to what's new. So I'll give Matt a moment to walk all the way over here. So far. It's a big room. It's probably easiest.
Oh, thank you, sir.
Cool. So, as always, we'll start with what's new in Sydney.
Oh.
AWS IQ is now available in Australia.
Finally, after everybody else has already gone and gotten their profile set up and got their customer feedback and all of that, we're now able to jump in and start off with a review score of 0. So, what is it? Australia, Asia, parts of Europe, opens up a fair number of places.
Yep.
Anybody not know what IQ is? Fair number of people. Amazon IQ is a way for AWS certified people to list their services available on and in the AWS management console. So you can actually procure the services of an AWS expert, get them to build, develop whatever it is you're looking for, have it delivered through the AWS management console, and then appear on your AWS bill. So it's a real nice way to be able to engage contractors without having to sort of leave the AWS ecosystem.
Yep. And until earlier this month, you could only have contractors from basically the US and maybe one or two other countries.
Yeah.
But nobody local. So that's nice. On to the serverless side of things. First one was an interesting one, which is parameters and secrets Lambda extension. So I haven't personally tried this one out yet, but my understanding is that instead of needing to do API calls and a lot of all the extra things, usually you can instead, using this extension, pull in your secrets through URLs, which should also be more secure.
The nice bit about this one, I don't know how beneficial it is for most workloads. The way AWS sell this is you don't need to pull in the SDK in order to be able to look up parameters and secrets anymore. You can simply use IAM and then just do a REST call to a HTTPS endpoint in order to get the value. It's also meant to give you the ability to cache it, so potentially reduction in cost. The serverless connectors was the interesting one for me. Additional to SAM, where you can simply define the relationship between different SAM or serverless application model components, and then have SAM automatically develop the IAM role for you in order to support the communication of your read and writes between components. Potentially useful. I'd be wanting to double check what it generates. Maybe dev test, validate, and then tweak for prod.
Yeah, but it is quite nice that it does some of the work for you, and that way makes life easier again.
Anything that makes life easy is good.
Yeah. The other ones are mostly smaller things, can still be interesting if it's something we're dealing with, but let's move on. So on the container side, the main one for me here probably was an announcement from just this morning that I really don't know the correct pronunciation for this, whether it's CDK8 or CDK8 or
Kates, yeah.
something. Basically, CDK for your Kubernetes configuration. So you can, just like your infrastructure, you can just build your code as CDK. Of course, you can do it really terrible, and I propose nobody does this, but there are all the ways you can spin up your AWS infrastructure using Kubernetes. So technically speaking, this would allow you to write CDKs for your Kubernetes things that then in turn spins up your infrastructure stack.
Yeah.
Don't
do that.
Yeah. Probably would make for a fun demo, but don't do that.
Yeah, things you can but probably shouldn't do in the real world.
Yep. Cool. Other things here, if you run ECS on EC2, you can add some new metadata endpoints for service name and VPC ID, which can be useful. Windows Server instances use Docker Community Edition, because the one it was using is going to charge money, and AWS does not want you to pay other companies. I mean, they want to make sure that none of us pay more than we need to.
Yeah.
And
yeah, EKS Anywhere. Yeah, you shouldn't be using EKS Anywhere. And Bottle Rocket. Yeah, again.
Yeah, that's more actually a security thing, but
yeah.
Cool. Then on the DevOps side, I actually found the spot instance interruption testing with the FIS quite useful. Basically, this allows you to So if you're not familiar with the fault injection simulator, it's basically a way to inject faults into your systems. I forgot the term for the type of thing it is.
Chaos engineering.
Thank you. I'm a bit chaotic. But so spot instance interruptions are one of those things that are hard to test, but really important if you use spot instances. So it's really nice to be able to test that.
Yeah. Aurora Serverless V2 on CloudFormation because, yeah, I needed that 2 weeks ago. So, of course, it's just come out. That's how CloudFormation works. Yeah, so, the service has only been available for what, 15 months now?
No, not in GA. That's less.
Yeah. But it's finally made it to CloudFormation.
Yep, which is good. And it's mostly here because last month's talk, where this was called out as one of the downsides of Aurora Serverless V2. So it's great to see that being fixed.
That seems to happen a lot. This user group calls things out and then the very next month they're released.
I'm not gonna.
That's happened a couple of times this year.
Yeah. Not saying there's any connection there. Is anybody here from AWS?
No, we're good.
Cool. Think that's it for the major ones.
Oh, no, we have to mention Corretto.
Yeah, of course.
That's the rules.
Correct. Then on the security side, so one that is worth calling out is that we've got a rename of a service. The AWS Certificate Manager Private Certificate Authority is now just called the AWS Private Security Private Certificate Authority. So a bit less double up, and a good name change. Happy that happened. Actually, I'm happier though about Managed AD now finally supporting something newer than
2016.
Yeah. Which means that if you are running a Managed AD, you can use more of the newer features. I don't think they're that new anymore, considering it's still 2019. But it's good to have. Footnote on this every new Managed ID that is spun up now will be running on 2019, and there will be automatic background updates of all the ones starting, I think, in March, if I remember correctly.
The other one is IAM Access Analyzer, reviews cloud trial history, trust policies. This is just a nice little feature addition for Access Analyzer. Just rounds out some of the context that you're going to get from using those sorts of services. And all these access analyzers, fault injection simulators, there's really starting to be a nice rounding out of services to help you sort of troubleshoot, debug, and make sure you're heading in the right direction. With over 200 services, it's starting to get a little complicated. So nice to see that they're sort of rounding that out.
Yep. I think then we move on to everybody's favorite announcement, which is the dark mode in the console. I've seen quite a lot of people being happy about it. You'll have to go to the new settings thing to turn it on. It's fine, it's dark.
Yeah.
I've tried it, I probably turned it back again. Other things, the TRN1 or Trainium instances are now GA. These were announced at reInvent last year, so it's good to see that they came actually out before
reInvent this year.
Let's hope the same happens with the Graviton 3 instances. Probably not. As the name implies, these are very machine learning focused. Also not yet available in Sydney. So hopefully before next reInvent.
And Amazon Connect cases. Yay, more Connect. I'm going to have to come back next year and do another talk with all the new features around this one. Yeah, you can do case management within Amazon Connect now. You probably wouldn't want to, but for a proof of concept, sure, it probably makes sense.
Yep. And the Amazon file cache, however it's pronounced properly in Australia. Basically, this is a layer that you can put in front of different file systems. So this includes S3, but also on-prem things and FSX for Windows and all that stuff. So you can connect to a single endpoint. And I actually haven't, this is also very recently announced, and I didn't look at the details yet for how it works. But if you've got a lot of disparate file systems and you want to make it easier for everybody to use them, this might be the service for you. And I think that's
that's about it. 15 read replicas for databases for those people who need that many read replicas.
Yep. So cool. In that case, I think it's time we'll switch over to Peter.
Speakers.
Thank you.
Have that one back. Off.
Let me. While Peter is setting up, I'll give a quick introduction. Peter is an AWS serverless hero and the author of serverless architectures on AWS. He was previously the Vice President of Education and Research at A Cloud Guru and an organizer of ServerlessConf. Peter holds a PhD in computer science from Monash University, Australia, and is a very nice guy.
Thank you. Thanks.
So
that's like my second slide. Oh, that was like my second slide. So I can skip over it now.
Happy to be of service.
All right. Thank you. Awesome. Hello, everybody. Nice to see you, all of you. So my name is Peter Zbarsky. Thank you to Arjen for the introduction. And wait a second. Check. Okay, we're back. Must not press the button. Well, I want to talk to you about my adventures with serverless. I actually titled my talk Dancing with Serverless because I thought it's going to be like George Martin's A Dance of Dragons, you know, only with fewer dragons and more Lambda functions. Yeah. See, this is the response I got when I tried this line at Yao in Perth a month ago, and nobody laughed either. And I can tell you, when you practice in front of a mirror at home, it's a lot easier. So there you go. So this is me. As Arjen said, I am an AWS serverless hero, which means that I talk about serverless and AWS a little bit too much. I am an author of a book called Serverless Architectures on AWS, and here are the covers. I've actually been very fortunate to have had the book translated to Mandarin, Chinese, and Japanese as well. I organized the Melbourne Serverless Meetup. Please come along. We have our next meetup, as Arjen said, on the 8th of November. Now, I'll be doing exactly the same talk. So if you love it today, you can listen to it all over again. Brilliant. I'm hearing like murmurs saying, yes, I'll attend. So thank you. I previously worked for a company called A Cloud Guru. Has anybody heard of that company? Okay, wow, a lot of people. Thank you. I was VP of Content and then VP of Education and Research, and I'll talk a little bit about our serverless journey as well. I used to organize a conference called ServerlessConf, where, as you can guess, we just spoke about serverless. It was serverless for like 2 days in a row, and yeah. But it was kind of cool because we brought speakers from AWS, from Microsoft, from Google together, and it was like all cutting edge development in cloud computing. So a lot of fun. Now I'm building something new, and I will talk a little bit about that later as well. So by the way, this is the second edition of my book. Check it out. This is a photo of Jeff Barr. He's the chief evangelist of AWS, holding a copy. So you know it is real, it exists. After I saw the photo, I thought I made it. Yeah, I mean, I don't know if Jeff has actually read the book, but I know he has a copy, so that's good. And that gives me a good sense of accomplishment. So Jeff, if you're watching this later, I hope you liked it. So when I started thinking about this talk, I was like, what can I talk to you about? And I decided to share a few of my experience building serverless architectures. And I will share some lessons that I learned. I will say a few things that are potentially controversial. So please, hear me out, but tell me what you think. I want to learn from you just as much. And yeah, it's going to be an interesting session, I think. So this image, by the way, is my attempt to use DALL-E to show me thinking about cloud computing. So I don't know, maybe it's not that bad, actually. Maybe this is me in a couple of years. Don't know. So I previously mentioned that I used to work for A Cloud Guru. Now, for those who don't know, A Cloud Guru creates and distributes online courses. And it's primarily a serverless company. It was started in 2015 by Sam and Ryan Cronenberg brothers. Ryan created content, Sam built the initial platform, and he did it in about 4 weeks. And the reason why he did it so quickly was because he had a full-time job and he had 4 weeks of holidays, and he knew he had to do it really quickly. The initial platform that he built was actually quite impressive. You could watch video lessons, you could do online quizzes, buy courses. It had all of the kind of the expected bells and whistles that good e-commerce platforms have as well. And because it was just the two of them, I joined, I think it was like February of 2016 as the first full-time employee. It needed to have a very low operational overhead. And scaling was very interesting. I remember, I think it was Black Friday 2016. So we were sitting actually in Vegas at reInvent. And we did something like 40 times the amount of transactions that we would normally do on any other day. And the platform just scaled wonderfully. We didn't really have to do anything to it. We sat there watching it, and it was kind of like magic. And like I said, it was all serverless and serviceful, meaning that we used a whole bunch of third-party services like Auth0 for authentication or Stripe for payments that a lot of other companies do. We really just wanted to avoid re-implementing common functionality. And so here is a very simplified diagram of that initial architecture that launched, I think this is 2015, early 2016. So we had an SPA website. It was written in old AngularJS. Does anybody remember the old AngularJS? Yes, I still have nightmares, just like you, sir. So users would authenticate via Auth0. Protected actions like purchasing a course were performed in Lambdas, which were fronted by an API gateway. The database that we used, interestingly, was Google Firebase. I don't know, am I going to be kicked out now? Sorry, yeah. But interestingly enough, what's cool about Firebase is that it can communicate with the front end, with the website, using WebSockets, right? So it doesn't need to go through Lambda to return a response. So any changes made to the database kind of immediately show up in the UI, which makes for a nice user experience. Our video files were stored in S3. And you may notice something interesting about this architecture on screen. It is actually a serverless monolith, right? There's one database, which is Firebase. And then there's a whole host of Lambda functions just writing to the database or getting data out of it. And the front end is actually coupled to the database as well, which makes it a super monolith. But you know what? That was okay. It worked. It scaled relatively well, given our size at that time. And importantly, it got us to market really quickly. as we grew, we realized that we needed to evolve our architecture. So this is around, I'd say, 2017, maybe early 2018, this architecture that you're looking at. We decided to move to a more microservices style architecture. And the big driver for it was actually our team structure. It wasn't technology. Because as our company grew and we brought on full development teams, we realized that our architecture had to grow with it. And moving to microservices allowed us to achieve acceleration with really highly focused teams who would own and become accountable for each particular service or area of the system. And so we had a team accountable for the student experience, a team accountable for the business experience, for exam taking, for e-commerce, and so on. And as you can see in this diagram, we moved to a GraphQL-based approach, where we had a GraphQL hosted in a Lambda function behind an API gateway, of course. Now that endpoint, that GraphQL sitting in Lambda, could query multiple microservices, which were really just collections of Lambdas with their own DynamoDB table. The GraphQL endpoint would use schema stitching to create responses for the client. And it could talk to multiple microservices and kind of come up with that appropriate response. An interesting element of this architecture is that we were still using Firebase over there, and we actually began using Algolia for search. So Algolia, it's a third-party excellent service where you can create searching for your website. We used DynamoDB event streams to capture updates and intelligently update Firebase and Algolia. So we could still maintain that great user experience, and we could migrate carefully and slowly, thoughtfully, without having to do an entire database migration upfront. You can actually think of this Firebase database here as a materialized view of our DynamoDB databases, which powered our user interface. And by the way, thinking of Algolia, I actually tried to use Amazon Cloud Search instead of Algolia. Has anybody ever tried? Does anybody know that that service even exists? Yeah, well, don't do it. So don't. Terrible. I think AWS gave up on it a long time ago. So think about this. We migrated our monolithic architecture to microservices without even really having to think about infrastructure, right? We didn't need to think about server provisioning, web farms, load balancers. And over time, we re-architected our system one piece at a time, simply by changing a YAML file, right? And redeploying. CloudFormation just seamlessly upgraded the system for us as we evolved, and it kept running. And one thing that I do like to show is what was happening to our system at the time and what we paid for it. So this is around July 2018, I think. So we had 289 Lambda functions grouped into 19 microservices. We stored about 3.7 terabytes of data. So these are video files in S3. That month, we did 107 million Lambda invocations with 45 million API requests going through the API gateway. We had an egress of about 3.8 terabytes of data coming out via CloudFront. So this is people streaming videos of our courses. And we had roughly 650,000 users. So I'm no longer with the company, so I'll show you the bill, what it was. This is the bill for that month. It's kind of interesting, right? Cloud watching CloudFront, the most expensive items. Lambda compute is only like $700. It's interesting. This is 2018, and we should remember that AWS never raises prices. So I was thinking that maybe these days, like if we had to repeat it today, the cost could actually be lower even. And I should mention that for the first 2 years of the company, we paid nothing for compute and API. it was kind of amazing because we were entirely within the free tier that AWS provides. And we had virtually no infrastructure cost. So I think that actually helped our business succeed. So as we move forward, step into the future, our teams, of course, continue to evolve our architecture. So our teams added service discovery. So the GraphQL endpoint could now find which microservices to query, right? Things became even less coupled, but still the cohesion of the entire system stayed quite high. I should mention that this service discovery mechanism was built in-house. So this was before something like AWS Cloud Map. And I cannot speak for the for our team right now. Maybe they would use Cloud Map today. They wouldn't build it themselves. I don't know. But yeah, so they had a custom implementation. I mentioned previously that we used Firebase as the database, right? It would connect directly to the client using WebSockets and stream updates directly to the client, to the website, basically, as soon as any change in the database was made. And I have had people ask, if you get rid of Firebase and replace it with DynamoDB, how could you achieve the same kind of seamless, beautiful user experience? Because DynamoDB on its own doesn't have WebSockets built in, right? It cannot stream data straight to the client. However, API Gateway does have WebSockets built in, and you can kind of do it yourself. So at a high level, what you can do is this. You create an API Gateway with a WebSocket. Whenever a connection is made through that WebSocket, you get a connection ID, which you can store in a DynamoDB table. And then when you need to return data back to the client, you look up the connection ID in the database and invoke the appropriate callback through the API gateway. The API gateway sends data back to the client via the open WebSocket, and it looks nice and seamless. And granted, maybe this isn't as beautiful and elegant as having Firebase, which just does everything itself, but you do have control over the WebSocket, and ultimately what gets back down gets sent back down to the user. Yes, we have a question. Potentially, yeah. So the question was, would you use Redis as an alternative? Potentially, yeah. Look, yeah. That's another alternative. Yeah, I think when we were building this, we didn't consider Redis back then. So yeah, but today maybe, yeah. And I'll actually dig a little bit deeper into this in the coming slides. We may have a very interesting discussion coming up. But first, let me show you this slide. I think this is my favorite slide of the presentation. I do have less hair now. As I was putting that previous slide about WebSockets, I was reminded of something called mallet architectures. Has anybody heard of mallet architectures? No one. Okay, I'm gonna teach you something today. Probably completely useless bit of trivia, but at least you'll know this when you go home tonight. So Tim Wagner, the creator of Lambda, actually introduced me to this concept. So in real estate, mallet architecture refers to a building which looks classical or traditional on the front, but is modern on the back. So usually it's done to conform to some kind of like neighborhood regulation. In software, it's actually analogous. It's very similar, right? It's something that may have a conventional approach that faces the user, but a more modern approach on the inside, on the other side. So serverless mallet architectures, like WebSockets, for example, are stateful on the front and are serverless on the back. And then, of course, you can take this analogy further and you can talk about reverse mallet architectures, right? Which is the opposite, where you have conventional clients, where you have kind of like the serverless, stateless functionality on the front, and then conventional implementation on the back. And then you have like double mallet. So this is where you allow two conventional clients to talk to one another, but the way you marshal data between them is all done serverlessly and in a more modern way. So yeah, you can go crazy with analogies like this. It's kind of crazy. So, yes, yeah. But anyway, that WebSocket architecture is an example of mallet architectures. So tomorrow you can impress your teammates when you go back to the office, and you can be like, let's implement this as a mallet. See what they say. So my experience working on the platform at A Cloud Guru, writing my book, talking to brilliant people such as yourself, kind of helped me to understand some of the benefits and challenges of serverless systems. And a lot of the benefits that I experienced can be summarized like this. I'm probably missing a few, but going serverless and using services to kind of avoiding doing all the undifferentiated heavy lifting makes you faster. And I have definitely felt this, and I cannot go back. The scaling that you get from Lambda and other services is incredible. And initially it can be cheap or free, but you also have to understand what you are buying, because it can actually hurt you. If you have intermittent or choppy usage, for example, great, Lambda API gateway can be awesome. If you have a need for sustained ongoing processing, maybe that's not the best option. And you can definitely get into trouble if you're not careful. I think the most trivial example that I made this mistake a bunch of times, and I don't know if you have, I call it serverless cancer. Can anybody guess what I'm referring to? Yes, I can see nods. So serverless cancer is very simple. Let's say you write a file to an S3 bucket, and you make a Lambda function invoke on that file. And then accidentally, that Lambda function writes another file to that S3 bucket, which invokes another Lambda function. And it just keeps on going, right? It never stops. And then you make a mistake like me, where you write 2 files into the S3 bucket. And then you get an exponential explosion of Lambdas invoking on a bunch of files, creating more files. And then I get the bill, and then I cry, and then I beg AWS support to forgive me, because I would never, ever do it again. So you just got to be careful, right? Lambda is a supercomputer. It is incredibly powerful, but you, of course, need to be a little bit careful, especially if you're just starting out or careless like me. A serverless approach can be operationally efficient. Obviously, you don't need to think about virtual machines or deploying new clusters. It's amazing, but it doesn't mean that it is free of operational concerns. You still need to know what to do when things go down, right? You need to have a robust way to deploy your functions, make changes to the database, migrations, so on. If something goes down, your customers are not going to care that it is AWS's fault, right? So you need to think about resilience, recovery, how to escalate issues to AWS or other third-party providers. A great benefit of serverless is that it's not Kubernetes. Enough said. Thank you. Large architectural pivots or changes are possible, right? And again, if you're making changes, they're not going to be suddenly easy or free, but they will be manageable, maybe more manageable, because you don't have to think about how many VMs you need to provision or how to get them up and running. I think there could be a person trying to get in. Sorry, if somebody, thank you very much. We had a whole bunch of people, for those who are watching this on live stream, we had a whole bunch of people rush to the door to open the door for someone, so it's super nice. Yeah, look, you just need to think about the architecture and the code. And to me personally, that's more than enough already. And finally, and I think this one is really underestimated, I think that developers really, really love the serverless approach. They love using Lambda. They love using other AWS services. It's fun, it's engaging. The feedback loop is so short. And if you want to attract people to your company, you know, think about this. It's a big benefit, and I don't think it is talked about a lot. Just one bonus hint from me: don't go advertising, you know, looking for serverless developers with 10 years of Lambda experience. You will not find them. Look for developers who are enthusiastic about technology and learning. and they will pick it up and they will run with it and they will create magic for you. So those are the good things. But there are challenges as well. And I'm going to outline a number of complaints that I have heard. So number one complaint, I don't know if you agree with me or not, but it's hard to develop and to test locally, right? And I understand this because the typical experience has been this. You write a function, you deploy it to AWS, you run it, test it, see what happens. There's a mistake. All right, fix it, deploy it again, run it, see what happens. Tedious, right? Then maybe you start writing some unit tests. Maybe you start mocking, some inputs, run the function locally. Maybe you try using Cloud Stack and emulate some of the AWS services on your machine. It's just not great, at least to me. Integration tests are a bit harder. You may have to mock a lot of AWS services. It's just because the cloud is involved. There's that write deploy test kind of loop, and it's not the best, I think. It can be tricky to observe and monitor, but this is true for any distributed system, right? This isn't fault of Lambda or serverless systems, because once you have hundreds of functions or containers or whatever, and millions of invocations, things become hard, right? And frankly, things can become hard even with 10 functions, depending on how you kind of architected and designed your system. And Amazon CloudWatch is not the greatest service for helping you understand what's going on. And I said this line once, and there were like a bunch of AWS people sitting in front of me, and I felt so guilty just saying that CloudWatch is not good. So luckily, we don't have anybody from AWS. I say it out of love. I say it out of love because I use AWS and I love it and I want it to be better. Let's just move on. Some tasks are impossible to implement with a serverless approach. Can you convert a 2-hour video using Lambda? Actually, it's a trick question because maybe you can, and we will talk about it in a minute or 2 minutes. Or can you download a file from an old SFTP server? This still happens. Tricky. Functions are ephemeral. They will only run for 15 minutes. API gateway has a 30-second timeout. Other services have other limitations. And people are still worried about locking, right? I don't actually think that this is a bigger problem as some people think it is. Are you really going to move from one cloud provider to another, or even go back to like bare metal or your own data center? I mean, to be honest, if this is what you are seriously considering, maybe you have become Dropbox, right? So then congratulations to you on your success anyway. So I will now tell you how I am thinking and solving those challenges that I outlined to you today, how I'm kind of going about solving them. So I left a cloud guru earlier this year. I had a bit of a break and my hands started getting itchy. I decided that, hey, I want to build something, right? I'm a developer. In my heart, I just want to build something again. And so I set a few rules for myself. First of all, whatever I was going to build had to be serverless, of course. That just made a whole bunch of decisions easier. I had to be fast, right? I'm on my own. I need to have very low operational overheads. I need to move quickly. Given what I'm planning, I could potentially need a lot of computing and processing power down the road. And I also want to leverage as many AWS and third-party services as possible. I don't want to rebuild things again. If certain problems have been solved, I just want to use the solution and focus on what makes my thing, my product unique. And of course, I wanted local dev and debugging to be as easy as they possibly could. So I decided to build a wealth management system. So I wanted a system to help track net worth, budget, review transactions, give me insights into my spending habits, help me plan for the future, visualize my goals, track things like insurance and receipts, help me do taxation. Very ambitious, but I just wanted something to help me. And I should mention that I'm not a designer, so these screenshots do not look as lovely as I would want them to be. And also I'm looking for volunteers. So if you want to help test my system, give me feedback, please go to the URL, leave your email address, and I'll get in touch with you. I hope to see you on it. So I think the tech is very cool. Whether this product succeeds, we will see, because I think I still need to solve kind of the PMF, to figure out the product market fit. But I think tech-wise, it's interesting. And that's what I want to talk to you about now, how I am thinking and approaching certain problems. So to help with the implementation of my product, I decided to use the serverless stack framework. Is anybody using this framework at the moment? Has anyone used it? One person. Excellent. So I've used everything. I've used SAM, I've used serverless framework, Chalice, I've done my own bash scripts. SST is an interesting new framework and has a few really great features. So number one, the ability to work on your Lambda functions locally without mocking or redeploying your app. And I'll show you in a second what I mean by that. You get a handy console to view and manage your resources. And you get additional composable serverless constructs on top of CDK on which this framework is built. So if you're not familiar with CDK, and I believe we will get a wonderful presentation later, CDK stands for Cloud Development Kit, and it's really just a way to define your cloud infrastructure in code, right? So you use CDK with your regular programming language, like JavaScript or Go or C#, and you define your infrastructure. You can use regular programming constructs like loops and logic, conditions. You can create unit tests, etc. So SST builds on top of CDK, and which you can use directly as well if you want to, but it provides some additional constructs on top to make serverless applications easier. So again, as an overview, you get local dev and debugging of your system. It's built on top of the CDK. You get a console. You can see like a little snippet on the side. You get high constructs like function and config, which you don't normally get with regular CDK. And you get interesting new features like auth. And I want to mention auth. It has just come out. It's a brand new thing, really. I just want to mention it to you so you are aware of it and what it does. So I currently use a SaaS called UserFront for my authentication. UserFront, it's just like Auth0 or Cognito, except I find it more user-friendly than Cognito, and it's cheaper than Auth0. But here is what SST can do. It can deploy a few Lambda functions and API routes to handle authentication flows. It basically creates your own serverless and free authentication provider. It allows your users to authenticate using like via third-party providers like Google or Twitter. Or you can couple it with your email or SMS sender to send emails or SMSs with links that your users can click on, just like Slack does, for example. And once the user goes through the social provider or clicks on the link that you have sent them, they are provisioned with a JWT token, which is then used to authenticate and validate all subsequent sessions. And it's done like normal in your custom authorizer, for example, or just your Lambda. So the entire library is stateless, and all mechanisms are handled through these short-lived JWT tokens. So in a nutshell, you get a free passwordless authentication system that is fully under your control. And you can extend it to support, I don't know, corporate multi-tenanted SSO if you want to. You can keep claims or information about the user in your own database, just chuck it into DynamoDB. So each time they log in, you can look the user up. But you don't need to store or manage passwords. How cool is that? You don't need to have password reset functionality or password forgot functionality. And I think given that the world is moving to this passwordless future and companies like Apple and Google are starting to really kind of train users that security without passwords is possible, not possible, but actually preferable. I think this is really interesting capability to have this free, stateless, scalable, run in Lambda authentication system that is fully under your control. By the way, this framework is all open source, so you can go, you can inspect it, you can see what it does. Like, it doesn't cost you anything. At the moment, I think it supports a general authentication adapter for any OAuth 2 compatible service. It supports any OpenID compatible service. And I think it has specific support like adapters for Google, GitHub, and Twitch authentication. Or you can do the magic links in your emails or write your own custom adapter if you want. So kind of cool. Finally, free auth solution. But I think my favorite feature is that of live Lambda development. So SST allows you to debug and test Lambda functions directly on your computer while they are being invoked by AWS. And the way it works is that it proxies requests from AWS straight to your local machine. And you don't need to mock any services or use local stack or anything like that. And you don't need to redeploy anytime you make a change. So here's what it does. SST deploys little stub lambdas into AWS when you do your initial deployment. And then it creates a WebSocket connection to your machine, to your local client. So whenever AWS invokes one of those fake little stub lambdas in AWS, the request, the event object basically, is proxied seamlessly down to your machine. The actual Lambda function on your machine runs. And then the response is proxied back to AWS seamlessly, and everything continues to run there. There's a DynamoDB table that keeps track of connections. There's an S3 bucket that is used as temporary storage. But look, to you, it doesn't matter. It's all handled kind of like seamlessly and transparently. And that image I took from the SST website. I think it shows two stub Lambda functions in AWS that proxy requests down to your machine and then back up again. And what I can tell you from using this for a few months is that it works actually wonderfully well. I can save a function locally. I don't need to redeploy it. I can make any changes that I want. The only time I deploy is, of course, if I go to production or if I'm deploying that function for the very first time to create that little stub. And if you use something like Visual Studio Code, you can actually put breakpoints into your Lambda function, inspect local variables, step through your code line by line. This is how debugging used to work, right? This is how we used to work all of the time. And it's kind of like, wow, I know we've gone back like 10 years back into the past, but it's kind of awesome. I'm sorry, it's just so cool. Obviously, a function executing on your local machine is a bit different to it executing in Lambda in AWS. For one, you have more memory, you have more CPU. But if you're, just working on your system, if you're fixing syntax errors or logical issues, then what does it matter, right? The experience I get locally is incredible because I can code locally, save, put breakpoints, step through my code. It's actually quite cool. So yeah, no more of that save, deploy, test. Just do everything locally on your machine. Cool. Yeah, awesome. I don't know. I just love it. They don't pay me, by the way. They don't even know who I am. I just love what it does. So we spoke about SST, local dev, and debugging. But what about observability and kind of just knowing what's happening in your system? You can use CloudWatch and X-Ray, which I do as well. They are built in. They are okay. But yeah, they're not the easiest. So another tool that I use is Lumigo. Now, this tool you have to pay for, but it's nice. It's a nice product. It hooks into your environment. It pulls data. It actually represents you with useful, actionable insights. It groups things in a nice way. It's just, I don't know, I find it a bit easier to use than CloudWatch. Not affiliated with Lumigo in any way. I just like to use it, and people ask me what I use normally. That's why I thought I would share it. Cool. So there's a lot of information, and there's more coming up. until Ian just drags me off stage. I'll keep going. So I want to talk about my architecture a little bit. So my product is made out of a number of services. I have a core service, which kind of holds your portfolio. I have an exchange service, which does currency exchange calculations. It's actually going to be replaced with another SaaS soon, but let's put that aside. I have a history service, which backs up your daily history and changes to your portfolio. Cleanup service that deletes all the irrelevant data. An analytics service, which produces nice insights and beautiful graphs. An integration service. This talks to a bunch of third-party services that I use, like Plaid, which can then talk to your bank account. For example, if you want to link your bank account and pull in transactions for budgeting, that's the service that does it. And I have services that handle insurance and receipts and tax. So I'm not going to lie to you right now and say that I developed this beautiful microservices architecture that follows best practice. For now, while I'm still kind of figuring out my business model, I have made a number of, I'd say, technical concessions up front. And I'm doing this in a way that I am aware of, and I'm doing it kind of for speed because I need to build this and get it out as quickly as I can. So here's an example. I have two services. I have allowed certain Lambda functions in one service to read and write directly to a database in another service. So normally this is a big no-no in a microservices architecture, right? It's a bad idea to have this kind of coupling. Because if I make change to the database, now I have to go and update all possible functions that are talking to the database across all possible services that I have. I'm breaking all of the contracts. This is not a good idea. In fact, what I've done here is that I've created a serverless monolith as well, right? I have defined my beautiful microservices, but then I allowed functions to cross boundaries. And once you allow that to happen, you're back to a monolith. You've lost your cleanly isolated services. So how do I fix it? What's a good way? And I think this diagram spoils it already a little bit, because one way to fix it is, of course, to make sure that everything goes through an interface, right? If a microservice has an interface, for example, it could be fronted by an API gateway, all requests need to go through it. So this is akin to having an interface for a class, right? We don't know about the inner workings of the class. The inner workings may change, but as long as we adhere to the main interface, we're good to go. And then, you can introduce some cool testing using packed or packed flows. You can make sure that the interface stays consistent. It could be awesome. It's a solid approach. It works nicely. Although, to be honest, in some situations, I don't know, it may not be amazing because there could be extra latency that is introduced by the API gateway. Sometimes complications can arise if you have like a chain of services that need to be called. But honestly, in a lot of situations that are not super complex, this is fine, right? But we know this, we're used to it. Now, if you don't need an immediate response and you're fine handling eventual consistency, meaning that things can be updated over a period of time and potentially in a different order, event streaming is a solution that is very popular. And, conferences love talks about event streaming. So if you go to, say, YAO, which is going to be in December, I'm sure there'll be like a bunch of talks about event streaming there. And you can use the capability built into DynamoDB to stream all changes made to the database, like updates or deletes, and have other functions invoke on those messages and update other databases. So DynamoDB streams captures a time-ordered sequence of item-level modifications. That's the official definition. And this produces kind of a looser level of coupling. And you're using the nice, robust capability and nature of DynamoDB and Lambda to do it. So remember this architecture? So we had a bunch of microservices, which would then go and update Firebase. We had this kind of like the write and the read databases, right? We would write to DynamoDB and we would read from Firebase. So you don't need Firebase at all to do this. Here is a super quick architecture of how you recreate that entire functionality just in AWS. First, let's get rid of WebSockets. We'll just do it without WebSockets using regular HTTP requests. So you create an API endpoint, create a function that writes to a database. Create a DynamoDB stream that invokes another function, which then updates a materialized view, like a read-only version of your database, right? Then you create a read API endpoint, and then you get data. So you have another function that reads from that materialized view. Very simple architecture. You have a read database, you have a write database. Maybe your materialized view can be enriched with some data. Maybe the way the data is presented or stored is different in a way. I don't know, but this is fine. So let's make our own version of Firebase. And if anybody does it and makes an awesome business, please remember where you heard it first. Don't forget me. So here's our version of Firebase. We have most of the architecture from the slide before. But the change we're going to make is we will make our materialized view publish events itself. Next, we will add a Lambda function to respond to those events. Then, as we discussed, if we have a WebSocket architecture, we have a DynamoDB table with connection IDs. So that client update Lambda function just looks up all the connection IDs, and then it publishes those changes straight to the API gateway. So this is basically like a super simple implementation of, I guess, Firebase that you could have. It's a little bit simplified, but this actually works. One word of caution, if you are using DynamoDB streams and you have multiple consumers, don't attach a bunch of Lambda functions to it. AWS will throttle you immediately. In fact, AWS states that you shouldn't have more than 2 processes reading from the same shard at the same time. That's bad. You will be throttled. So a better approach is to have a stream, have one Lambda function, grab the data from the stream, publish it to an SNS topic, and then you can have multiple subscribers on that SNS topic in a fan-out manner, consume that data, if that's what you need to do, right? If you need to have multiple subscribers. It's a much more scalable and AWS-approved way of doing it. And then you can evolve your architecture further, right? You can introduce event bridge, which is, next level. It's very powerful. It's a serverless event bus. It can support multiple consumers itself. It provides at least once delivery mechanisms, has exponential backup for 24 hours. It can integrate with Lambda really simply. It's kind of like that natural step forward that you can take. Publish your events there, have multiple subscribers directly attached to it. Yet another way, of course, if you want to coordinate multiple microservices, and I'm running out of time, so I'll be really brief and really quick, is to use step functions. Does anybody use step functions? Okay, a few people. So step functions is a great AWS service that really allows you to define workflows and do so in this robust, traceable way. And it's way better than the old, Amazon simple workflow service, which, as the old joke goes, was anything but simple. So step functions is great for distributed applications because it has built-in support for failure states, retries, parallelization. It integrates with a bunch of services, has good observability baked in. I really like it a lot. And I think one insight that I've learned from using it is that it's suitable as a workflow mechanism within a service at a low level, and also between services at a high level. It's very adaptable and flexible. And so I use it at different levels of granularity myself. And I was going to show, I'm running out of time quickly, so I'm going to skip through this example, but I was just basically going to show that you can orchestrate like a delete workflow if you wanted to delete some data, and you can have different ways of handling errors or issues, and you can do things in parallel or sequentially. And then, of course, you can orchestrate actions between multiple services at a high level, right? This is all possible. It's basically like a super cool and sexy ETL workflow pipeline, if I can put it that way to you. So in the 5 or 10 minutes I have left, I want to talk about some hard problems, difficult problems. How do we solve those? And I'm stubborn, and I just want to use a serverless approach when I can. One way to solve problems is to apply a principle like MapReduce and parallelization. Because, after all, Lambda is a supercomputer, right? So why don't we think about it as a supercomputer? And a couple of years ago, I kind of posed this problem for myself. Can I transcode a large video file with a serverless-only approach, right? How can you do it? How would you go about it, right? Big file, I don't know, a movie. I want to transcode it from 1080p to 720p or vice versa, or to 4K. And the solution that I'm about to propose to you, which I've implemented, it's only an example, right? If I was going to do this in real life, I actually wouldn't do it serverlessly. I would use something like AWS Elementals Media Convert. But what I want to illustrate to you is the kind of thinking that you can apply, because there will be situations where a ready-made solution doesn't exist. And actually applying this type of thinking can help you solve it in a way that's kind of neat. So MapReduce or divide and conquer. So how could we encode a large video file? So one way to do it is really to break up a big task into a bunch of smaller tasks and process them in parallel, which can be done with Lambda. It's perfect for that. It's very suitable. So if we had a very large file like that, we can split it up in Lambda in parallel. Then we can transcode each portion, hopefully doing it in parallel. And then we can remerge those little portions until we get a new file. And this actually works. So there's a blog post that I wrote that goes into a lot of depth. If you want to check it out, or check out my book, just check out the blog post. It basically goes into detail into how you can implement such a system. But at a very high level, chuck a file into an S3 bucket, invoke a Lambda function on it. That Lambda function runs a step functions workflow. You don't have to use step functions. I've had 2 implementations, one with step functions, one without, up to you. I ran a little utility called ffprobe. It's just an open source utility to analyze the file. And what it does, it analyzes the file. It lets me extract audio, which is saved into an S3 bucket somewhere, or EFS. Then I used a feature of step functions called dynamic parallelism to dispatch a whole bunch of Lambda functions to divide my video file into tiny, tiny, tiny little portions, right? And it would all run in parallel. It would create the little tiny portions of my video file and save those into an S3 bucket. Then, and I came up with a little algorithm, it would start converting those little video files and merging them together. At the end, I would save a new file into another S3 bucket. Don't do serverless cancer. Don't just save the entire new files into the same S3 bucket. I told you what happens. But save the new file into a different bucket and you have a new video. And I actually implemented the system, like I said, and this is maybe a couple of years ago, and I benchmarked my serverless Lambda approach against just running FFmpeg on my machine and running it on EC2. At least for my use cases, for the files that I tried, the serverless approach was faster in all but one cases. And that's because, when you just run FFmpeg normally, it's sequential, right? It Anyway, so I'll just finish off like this. I had like 10 more slides for your entertainment, but some of them were very good, but now you will not see them, unfortunately, unless you come to the serverless meetup on the 8th of November, because I will repeat the entire talk, plus the 10 bonus slides that you may not see today. But I just want to say that, look, modern development of serverless applications can be a lot of fun. I think some of the problems that we have all experienced are being solved or have been solved. So yeah, please check out SST as your potential development framework. It does solve the local dev and debugging challenge. Check out Omigo. And I think we're living in a very, very exciting time, and I cannot wait to see what Reinvent comes up with. It's going to be good, right? You have some inside knowledge. Reinvent, serverless?
I don't.
Okay.
I know nothing.
Okay. But yeah, anyway, thank you for listening. Sorry for taking up so much time. I just couldn't stop until the system stopped.
Thank you, Peter. That was great as always. I did promise people a little bit of time for questions. So if we have 1 or 2 questions while Daniel is looking into
I think people
fixing
are so
things.
burnt out. They're like, oh my God, please.
Our AV issues. It's turned itself off.
Yes. Yeah, so the question was, when you integrate with external systems, have you considered using EventBridge with adapters? So EventBridge can talk to a bunch of external non-AWS services in a nice and easy way. Yes, absolutely. I may do that still, haven't done it yet, but that is definitely a very viable and good option for consideration, 100%. May still come up. Maybe next year if I do talk revision 2, I'll talk about that too. Excellent question. Thank you. Okay. Thank you, everybody. People just want to go home now.
So it looks like the stream is actually working. So
Yeah.
What's into YouTube? What is it there?
So the stream is working, but this is not.
Screen is turned off.
I can work with that. Everyone happy to work with that?
Yes.
Cool. Do you want to intro me, or am I just doing this?
I'll get you an intro. That's a different intro. Cool. This one works better. Many of you already know Dawn, but I'll do an introduction anyway. Dawn likes to tinker with cloud infrastructure and security, and regularly goes down rabbit holes in a futile search for ways to develop systems that are both reliable and impenetrable. As well as accidental accessibility advocacy, Dawn can regularly be found sharing knowledge with the Melbourne cloud infrastructure and DevOps communities, such as this very one. And outside work, Dawn is an occasional author, kitchen alchemist, and raging sports ball fan.
And today, contrary to my usual presentation format, I'm not doing this with slides. I'm also, you would notice for those of you who have seen me present before, actually not wearing sports ball kit this time. There are 2 reasons for that. The first one is this is a lightning talk. I have no slides. The second one is waistcoats are always an ideal sartorial choice. Every system that we build is predicated on trade-offs. And that is true also probably for a very large percentage of the systems that we build outside IT. But in this case, the systems that we care about are IT, AWS, specifically, as you would know from the talk topic, CDK. I don't have the slides, so let me give you the very brief introduction to our friends at Product Core. Many of you will already know who they are. For those of you who don't, they are a startup headquartered in Sydney. They build e-commerce software. And one of the primary people that we tend to hear about a lot is Product Core's head of platform, And that is a person who goes by the name of Ben Nguyen. Ben Nguyen has recently re-architected a lot of the way that they have this all set up. And they have decided that for some of the work that they are doing, they are going to do it with CDK. CDK, as Peter said earlier, is basically a way to do your infrastructure as code using standard programming languages, the types of things that your devs would use. The advantage of CDK in this instance being that then you can actually sit down with your devs and go, hey, you are going to build your own infrastructure in the programming languages that you already understand. This is really powerful. It also means that you do not have to hire a bunch of people to maintain your CloudFormation or Terraform, nor do you have to train a bunch of people in CloudFormation and Terraform. You can build your resources in languages that people already understand. It's the DevOps of platform teams, the platform team of DevOps. I don't know. I haven't really finished thinking that thought through. But one of the problems with CDK, or one of the interesting rabbit holes that I went down when I started using CDK, is that in order to actually get CDK to do pretty much anything of any significant complexity, you've got to build out a few things first. And these things are all built out generally on the CLI using CDK bootstrap command. Typically, if you want to do this, you run the command, you will get back a bootstrap stack, and all of that is hidden from the view of everyone who uses the system. But if we put ourselves for a moment in Ben's shoes, one of their primary concerns with this CDK bootstrap stack is actually understanding what it does. And AWS will very kindly give you the whole template in CloudFormation so that you can edit it yourself. This is what, if you're looking on the live stream, you'll now be able to see. It's got a description. It's got some parameters. Many of these, that they have actually done a decent job of naming them so that it's self-explanatory. They have good descriptions. You can do all sorts of things with these parameters. You can actually basically do cross-account trust, which is set up then in the conditions block, which we can see at the top. But then in terms of what this actually creates, you get pretty much 3 different units of stuff. So you get a bucket which is used for assets, essentially the first 2 lines. And that gives you, that bucket is basically, all right, you want to build something with CDK and you have to upload some data to it, it goes there. You get a bucket where you can handle templates, and that's essentially the, all right, you want to build a really big CDK template. When we convert it into CloudFormation, we need to put that somewhere rather than fiddling around with things. Here is an intermediary bucket. This is where it goes. CloudFormation can then pull the data out. There are a few problems with this. There are a few security holes. There are a few rabbit holes which you can go down, and you'll not have a hell of a lot of fun going down them. Because those buckets, by default, pretty much open to everyone who has access to S3. The other problem with this is that when you create a CDK bootstrap stack, it actually creates 2 separate IAM roles. It creates the one that you assume into, and that role then goes away and assumes a CloudFormation execution role, which actually executes the code that you want to run. This is great. Anyone know what the name of the AWS managed policy that gives you full access to everything is? Administrator access. Anyone want to take a guess what the name of the managed policy that's attached to the CloudFormation execution role by default is?
Guessing it's not read-only.
Ian is absolutely correct. It is not read-only. It is, in fact, administrator access. So this means that if you go in and you deploy a CDK bootstrap stack, by default, anyone who has access to assume IAM roles in your AWS account can go in and deploy whatever they want using the CDK. That might be a bit of a problem for several different reasons. There are a couple of different ways that you can fix this problem. one of which I am going to demonstrate, one of which I am not going to. The one that I'm not going to demonstrate, the one I'm just going to explain is there are two different roles. Basically, there are two different IAM roles which you can manipulate here. You can change the policies on the CDK deployment role so that only specific people can assume it. You might change the policy so that the only people who assume your CDK deployment role are the people who have administrator access on your account. Another way of doing it, which I'm not going to demonstrate, is that you might actually set it up so that you have to use an OIDC provider to assume into that role. Basically, the workflow that's essentially enforcing is you can only deploy stuff with CDK from GitHub or Bitbucket or GitLab or whatever your other CI/CD provider or third-party tool that you are using to do this is. But that still leaves you with the problem that the CDK bootstrap stack at that point can do everything. Fortunately, because AWS actually provides you with the template for the CDK bootstrap stack, you don't have to use the CDK bootstrap command on the CLI. You can actually go in and do whatever you want to that bootstrap template. So can everyone, because I can't see here, can everyone now see the CloudFormation execution role default policy on the stream? Awesome. So what you can do with this is you can pretty much set it up. So you can just create an IAM policy which gets attached to the CloudFormation execution role in the Bootstrap template, which will then allow you to limit the scope of actions that people can perform here. In terms of limiting the scope of actions, this particular policy, which is up on the screen at the moment, is allowing organizations EC2, ECR, but we don't really care about what it allows. We care more so about, if I actually drop all of these down, and if you're doing stuff with SSM, do be careful to make sure that you don't give full permissions to everything in SSM because that will stuff you up. Pretty much all you need to do is you create a policy document, you set the statements that you want, you basically say, these are the things I want you to be able to do. And then you attach that default policy to the CloudFormation execution role. If you do that, you have now scoped down what you can actually do with this. Another thing that you'll notice in the Bootstrap template is right up here on line 27, you've actually got a qualifier. And that allows you to differentiate different CDK Bootstrap stacks from each other. So if you really want to, you can deploy 15 or 20 of these, all with different permissions to be used in different scenarios by different teams. And some of those may be scoped down using OIDC providers. Just in this case, don't fall into the trap of doing this the way that AWS does and thinking that the CDK Bootstrap stack is just a magic abstraction. Because as Benwin would tell you in their time at Product Core, actually understanding how the systems work is critical to being able to produce something that doesn't give us problems like all of the data breaches that we've been hearing about in the news recently. So if there's one takeaway from this, please don't be Optus or Medibank. Yeah, there's a new one every minute. Anyone have any questions?
No.
So do you see the end game for an organization that's using this instead of something like Terraform is to create their own sort of domain / organization specific sort of Terraform thing?
I absolutely do not care which tool you pick. I just care that if you decide that you are going to use CDK, you are aware that CDK does not use the permissions that attach to users. I don't think that CDK itself inherently is a tool that makes it easier to do that. It's merely that CloudFormation and Terraform take the permissions of the user or take the permissions of basically the IAM entity directly. CDK doesn't. And if you want to use CDK, that's a really important thing to understand.
Okay, so you don't have a lot of, I guess, knowledge about how organizations have used one or the other and whether it's been better or worse, or apart from the security implications you're talking about?
I don't, the choice of tool, I actually gave a presentation about this at the AWS user group 3-4 months ago, maybe closer to 5. The choice of tool, CloudFormation, Terraform, CDK, the TLDR on that is it should be entirely about how quickly you want to deploy things, how quickly you want them to actually deploy, what the skills are that you have in your teams, and how you want to divide up your teams. The security implications shouldn't enter into it. This is just a fun little rabbit hole that I went down.
Okay, thanks.
Well, the security implications should enter into it in that you need to understand what they are.
Anyone else? No? Okay. Thank you very much, Dawn.
And I will
That
leave you
was-
to it.
So I'm going to plug in my laptop, even though for everybody here, that doesn't matter at all. But technically speaking, it should mean that people on the stream can hopefully see this. Beautiful, isn't it? So a couple things before we get up. First thing is the marketplace I mentioned. Anybody who is hiring, can you please stick up your hands, and I'll come by and let you give a 30-second or so spiel about who you are, what you're looking for, and obviously what company you represent. I'll just, because everybody's so spread out, I'll just start closest and work my way backwards. Yep.
Hi, I'm Ilya. I'm from Smart Bear. I'm an engineering manager that's in charge of a newly acquired startup, Melbourne startup called Pact and Packflow. I think Peter mentioned that a little bit in his presentation. So we are looking for engineers that know Ruby, that are polyglots, so they don't mind if they know Java, Kotlin, whatever. Essentially, the team is very small because we were a startup beforehand, but we're doing really big things in terms of helping people test their microservices, their contracts between microservices. And yeah, we're now part of a very large Smart Bear company. I'm sure you guys heard of, or maybe you haven't, Swagger Hub. That's, Cucumber. So yeah, so find us on LinkedIn. There's a couple of advertising at the moment for the role. And yeah, hope to see you guys.
Cool, thanks.
Hi, everybody. My name is Brinley. I'm an engineering manager at Amazon, not AWS, but Amazon. So I sit within the ads division, and we are actually building a local Melbourne-based engineering team, here in Melbourne. So I'm actually hiring for multiple roles. We're looking for SDEs of various levels, QAEs, SDAT. So SDAT is software engineering test engineers. So yeah, we're building a local team based in Melbourne. So feel free to reach out. I'm not sure how we're going to send the link. So I've actually got the roles advertised on LinkedIn and also in Amazon Jobs website. Yeah, that's me.
G'day, my name is Peter. I'm from Wes Farmers One Digital. If you haven't heard of us before, we just launched onepass.com.au. It's a subscription program that's integrated into some of the biggest e-commerce platforms in Australia, like Kmart, Bunnings, and Catch.com.au. We've got a bunch of engineering roles open, back end, full stack. I think we've got one more like senior cloud role in the platform team. Dave's also from One Digital. Do you want to talk about your roles?
Hey, my name is David. I'm head of information security for One Digital, West Farmers, One Digital. As already mentioned, it's a fancy new startup from West Farmers. And I have some security engineering roles, mostly on AWS, but a little bit on the Blue cloud provider as well. If you want to play with fancy state-of-the-art security stuff like Zero Trust and a few other shiny tools, come talk with me. Roles are in LinkedIn as well.
Thanks. It's Thomas from Four Quarters. I speak every month. You'll know that I'm one of those recruiters. I do also recruit not just AWS, but Microsoft as well. So if you do actually have any Azure skills, I'm in demand for a few of those. I am actually recruiting a serverless role at the moment as well, contract role. But if not, if you just want any help, any tips on the market, how you see the market going, any information, feel free to hit me up on LinkedIn or come and speak to me after. Thank you.
Yep.
Hi, everyone. My name is Arshit. I'm a DevOps engineer at Whisper, which is a communications platform. We're looking for a few DevOps engineers. It's a fully remote position. You'll be working with mostly AWS, lots of ISE, all in Terraform. It's a great company. Lots of smart people get to work with. And yeah, so mid to senior is sort of what we're targeting. If you're interested, you can go to our website, whisper.com. So that's WHISPIR.com, or you can come and talk to me as well. Cool. Thanks.
Cool. Did I miss anyone?
I promise I don't just live to make Iron's life difficult. And I also know that if you've been here before, I do the pitch for Enabler pretty much every month. If you want to build on Kubernetes, I know that a lot of people here have particular views on Kubernetes. If it's something that you're interested in actually doing properly, I think we have the foremost expert in certainly Australia, probably Asia Pacific, on when you should and shouldn't use Kubernetes in Pratik. If you want to come and play around with AWS, if you want to come and work with a bunch of really smart people, we consult at all kinds of places. Come find me, ask me questions.
Cool. Do a quick plug as well. I work for CMD Solutions, gold sponsor of this very meetup. That makes them a really good company. They're also service partner and migration partner of the year for Amazon, for AWS, as well as best place to work in Australia, which all makes it awesome. It's consultancy like Enabler. I'm not going to take up everybody else's time about this, but always good. The next slide you can't see is for thanking our sponsors again. So once again, go out CMD, Versant, and CIVO. And then the last slide that you also can't see is about our next meetup, which is going to be a week earlier than usual because AWS did not consult us when they planned reInvent. And we decided, well, we'll give them the spotlights this month because I know everybody wants to come here instead of reInvent. So the next meetup will be on the 23rd of November, and we'll be back then in our usual venue on 395 Burke Street. So with that, I will thank you all for coming. Feel free to hang about a couple minutes, but I think then we'll need to be moving on. So thank you all and have a good night.
Yeah. Reese, yeah, when they did Reese, they have the same.
Oh,
It
really?
shut off. It shut off at night.
Oh, yeah.
Thank you.
I actually get it.